Bismillahirrahmanirrahim. Assalamu alaikum, students. In the last lecture, we discussed the idea of center of mass. We said the motion of systems of particles is described in terms of the motion of center of mass. Today, we take this topic to the conclusion and we generalize our ideas. So I write here many particle systems write it, or I should write this way: center of mass of n particle system in three dimensions, right? Center of mass of n particle system in three dimensions. So we consider a system of n particles of masses m1, m2, and so on up to mn. And let capital M be the total mass of the system, which is equal to m1 plus m1 plus m2 plus so on plus mn. So this is my total mass of the system, right? Now I can write this total mass in compact form: summation m subscript small n, where small n runs from 1 to capital N, right? Now the center of mass, since we are talking of three dimensions, center of mass will be located by three coordinates: xcm, ycm, and zcm. So xcm, x coordinate of the center of mass, is given by 1 over m m1 x1 plus m2 x2 plus so on plus mn xn, or I write it in compact form: 1 over m summation m subscript little n x subscript little n, right? We know little n or small n runs from 1 to capital N. So I name this equation A, right? Similarly, the y coordinate of the center of mass, ycm, will be given by one over m1 y1 plus m2 y2 plus so on plus mn yn, right? Which is equal to 1 over m in compact form summation m little n y little n, right? I name it equation B. Similarly, we will have z coordinate for the center of mass, zcm, equal to 1 over m1 z1 plus m2 z2 plus so on plus mn zn, or in compact form 1 over m summation m subscript little n z subscript little n, right? And name it C. Or I can combine these three equations into a single equation using the idea of vectors. So combining A, B, and C, right? We can write the information contained in these three equations A, B, and C in a single equation using the idea of vectors. So I write RCM. Now it is vector. What is RCM? Position vector of the center of mass. It will be 1 over m1 r1. What is r1? Position vector of particle. 1 plus m2 r2 plus so on plus m n rn. Rn being the position vector of the nth particle. Or in compact form, I write it 1 over m summation m subscript little n r subscript little n, right? I name it equation first. So this equation 1 contains all the information contained in three equations A, B, and C. I want to remind here to you, must be knowing it. Just a reminder, RCM is a vector, position vector of center of mass. It will have three coordinates, XCM, YCM, and ZCM. That means RCM vector will be XCM I cap plus YCM J cap plus ZCM K cap. Similarly, I would show for particle 1, R1 vector would have three coordinates, three components, X1 as its X component, Y1 J cap plus Z1 K cap, right? The XCM, YCM, ZCM are the components of RCM. X1, Y1, Z1 are the components of R. Same goes for other position vectors, right? Now if we differentiate equation first with time, we can find the VCM. So differentiating equation 1 with time, differentiating equation 1 with respect to time t, we get VCM, velocity of center of mass, is d by dt of RCM, which is equal to 1 over m1 d by dt of R1 plus m2 d by dt of R2 plus so on plus mn d by dt of Rn, right? Or I can write it 1 over m1 v1, because v1 is time derivative of R1, velocity of particle 1 plus m2 v2 plus so on plus mn vn. This is my velocity of center of mass, or I can write it in compact form 1 over m summation m small n v small n subscript. I name it equation second. It gives me the velocity vector of the center of mass. Differentiating equation 2 with time will give me acceleration of the center of mass. I use another color. I write differentiating equation second with respect to time t, we get, so I get ACM vector, acceleration of center of mass, d by dt of VCM, which is 1 over m. I write it directly, m1 a1 plus m2 a2, right, plus so on plus mn an, because d by dt of v1 is a1, acceleration of particle 1, d by dt of v2 is a2, acceleration of particle 2, and so on. But I write it in compact form 1 over m summation m subscript little n an. Let this be my equation third, right? So first gives me the equation first gives me the position vector of the center of mass. Second gives me the velocity of center of mass. And third gives me the acceleration of center of mass. Now, from equation third, I can conclude a result. Equation 3 says MACM is M1A1 plus M2A2 plus so on plus MN AN. I have just taken this capital M in equation 3 to left hand side. I got MACM equal M1 A1 plus M2 A2 plus so on plus MN AN, right? This is my equation. Now from second of Newton, from Newton's second law, we know mass into acceleration of the particle is what? It is simply net force on the particle. So that means M1A1 is what? It is net force on particle 1. So I can write it. I think I should use another color. This is actually net force on particle 1, F net 1, plus net force on particle 2, F net 2, plus so on, plus F net N, net force on particle N. Simply replaced mass acceleration product by net force on the concerned particle, making use of Newton's second law. Now, net force on particle 1, we are talking of a system of particles. Let me write it here. I have a system of particles M1, M2, and so on up to Mn. This is my system, right? Now, net force on particle 1 will be because of other particles in the system and some external mass. So there can be some external agent exerting force on M1, and there may be forces on M1 due to 2, 3, and other particles. Now the force on M1 due to the rest of the particles in the system, those forces are internal forces on the system, and the force on M1 due to external agent is external force. Same is true for M2. Net force on M2 will be due to the forces on it due to other particles in the system and the force due to some external agent. So we can split net force on any particle into two parts, internal force and external force. So F net 1 can be written as F internal 1 plus F external 1. Similarly, F net 2 is F internal 2 plus F external 2 plus so on. Another color, F internal N plus F external N, right? So we have separated net force on particle 1 into two parts, F internal force on particle 1 and F external force on particle 1. Similarly, for other particles, this is F internal 2, that means internal force on particle 2, this external force on particle 2. The same goes for every other particle. Now, you know from Newton's third law, from Newton's third law, we know if we have two particles, M1, M2, and they exert mutual forces on each other, if F1 is force on particle 1 due to 2, and F2, 1 is force on particle 2 due to 1, F1, 2 is minus times F21. Simple. I said if I have two masses, M1 and M2, F12 is force on 1 due to 2, and 2 is F21 is force on 2 due to 1, F12 is minus times F21. Because of this reason, all these internal forces in this sum cancel out. Because for every, in general, for every Fij, that's force on ith particle due to jth particle, there exists in this sum Fji. Understand this, I am saying in this sum, all internal forces will cancel out because of Newton's third law, because for every Fij, there will be Fji in this sum, Fij being the force on ith particle due to jth particle, Fji being the force on jth particle due to ith particle. In the sum, this will be minus times of other one, so they will cancel out. So what remains? Only external forces. So what I get M ACM is equal to what? F external 1, F external 1 plus F external 2 plus so on plus F external N, right? External 1 plus external 2 plus external N. It's my equation third. Now I write it this way. Sigma F external. Sigma F external is the vector sum of all these external forces. That means net external force on the system. I write it this way, this equation, sigma Fx is M ACM. This is an important result. This is my equation 4. Right, this is my equation 4. Why we can do this? Right, in the bracket, because all internal forces cancel out, right? This is how we write Newton's second law for a system of particles. It's an important result. You can write it in component form. You can write this into 3 equations like this. Split it into components. Sigma F external X. That means algebraic sum of all the X components of external forces is mass times the X component of the acceleration of center of mass, sigma F external Y is M ACM Y, and sigma F external Z is M ACM Z. What is ACM X? X component of acceleration of center of mass. What is ACM Y? Y component of acceleration of center of mass. ACM Z is Z component of acceleration of center of mass, right? So you can see from equation 4, the overall translational motion of a system of particles can be analyzed using Newton's laws as if all the mass were concentrated at the center of mass and the total external force were applied at that point. I write equation 4 tells us, I write according to equation 4, the overall translational motion translational motion of a system of particles can be analyzed using Newton's laws as if all the mass were concentrated at the center of mass and the total external force were applied at that point. The overall translational motion of a system of particles can be analyzed using Newton's laws as if all the mass were concentrated at the center of mass and the total external force were applied at that point. This equation 4 justifies the definition of center of mass, justifies the definition of center of mass, that it is a spatial point in a system of particles which behaves like a point mass of mass equal to total mass of the system under the action of external forces, because in this equation acceleration is of center of mass m is of the mass of total system, and external force acts on the center of mass, right? So it behaves like a point particle of mass equal to total mass of the system under the action of external forces. And corollary of equation 4 is if external force on the system is 0, right, then what will happen? Acceleration of the center of mass is 0, implies velocity of center of mass is constant. That means if the net external force on a system of particles is 0, then the center of mass of the system moves with constant velocity, right? So this was the center of mass of n particle system in 3 dimensions. Now we do a sample problem together in order to understand the idea of center of mass. I will draw a figure follow me. This problem will help you understand center of mass. So I name it sample problem. So let me draw a figure first. Going from this side. This is my origin. This is x axis. This is y axis. So let this be my 1, 2, 3, 4, 5. Right? And that means another color. And this is my -1, -2, -3. Right? Draw the figure with me. This is my 1, 2, 3, 4, and it's my -1, -2. Okay, it's sufficient. Now M1 is at, let me draw the grid. 3. Right? Another color. So I have here the particle at this coordinate, x equal to -2, y equal to +3. -2 plus 3. It has name M1. It is acted upon by force this way. That force is F1. Right? Then I have M2 located at 4, 2. That means this. Another color. So I have another particle at x is equal to 4 and y is equal to 2. This is the particle M2. Now another force acts on at F2. So F2 acts on it. This F2 makes 45-degree angle here with the horizontal. This is 45 degree. Then I have another particle at the location x is equal to 1, y is equal to -2. That is this. Another color. This is my M3. It is acted upon by another force F3 this way, parallel to x-axis. Right? So this is my figure 1. Right? Let me check the figure. So I have 3 particles M1. M1 is located at -2, 3, acted upon by F1. M2 is located at 4, x is equal to 4, y is equal to 2. Right? It is acted upon by F2. F2 makes 45-degree angle with the positive x-axis, horizontal. M3 is located at x is equal to 1, y is equal to -2. It is acted upon by F3. So let us write the problem. Figure 1 shows figure 1 shows a system of 3 initially resting particles of masses m1 equaled 4.1 kg, m2 equaled 8.2 kg, and m3 equaled 4.1 kg. The particles are acted on by different external forces which have magnitudes F1 equal to 6 Newton, F2 equal to 12 Newton, and F3 equal to 14 Newton. Then question says the directions of the forces are shown in the figure. Then where is the center of mass of this system, and what is the acceleration of the center of mass? Let me check the question. Figure 1 shows a system of 3 initially resting particles of masses m1 equal 4.1 kg, m2 equal 8.2 kg, and m3 equal 4.1 kg. The particles are acted on by different external forces which have magnitudes F1 equal to 6 Newton, F2 equal 12 Newton, and F3 equal 14 Newton. The directions of the forces are shown in the figure. Where is the center of mass of the system? And what is the acceleration of the center of mass? So first understand the problem. We have three particles shown. Their locations are indicated in the figure. They are acted upon by three forces. Those forces have directions indicated in the figure. Their magnitudes are given. It is said that these particles are initially at rest. That means before the application of the forces, they are at rest, right? Now, what is the question? We are asked to find, first locate the center of mass. It's a two-dimensional system. So to find the center of mass, we have to find xcm and ycm. Then we have to find the acceleration of center of mass, which is a vector quantity. That means we have to find its magnitude and direction. So let us solve it together. Solution. So first I will find xcm. From this equation, 1 over m1 x1 plus m2 x2, as I have three particles, m3 x3. If you chuck it, capital M is 16.4 kgs. That means another color. What is capital M? It's m1 plus m2 plus m3. m1 is 4.1, 8.2. So 8, 4 is 12. When you add 12.3, 12.4, 16.4. So total mass of the system is 16.4 kgs. Then what is inside the bracket? 4.1 kg into minus 2 centimeter plus 8.2 kg into 4 centimeter plus 4.1 kg, 4.1 kg into 1 centimeter, right? So when you calculate it, it turns out to be 1.8 centimeter. So I have calculated xcm. First understand it. 1 by 16.4 kg, which is total mass, then it is 4.1 kg into minus 2 centimeter, because m1, x coordinate of m1 is minus 2 centimeter. See, m1 is here, its x coordinate is minus 2 centimeter, right? Then there is m2, 8.2 kg into 4 centimeter, m2. m2 is here, its x coordinate is 4 centimeter. Then 4.1 kg is m3, its x coordinate is 1 centimeter. It's 1 centimeter x coordinate of m3. So when you evaluate it, you get the answer equal to 1.8 centimeter. So this is my xcm. This is not the full answer. I have found the x coordinate of center of mass. Then we find ycm using 1 over m1 y1 plus m2 y2 plus m3 y3. Again 1 over 16.4 kg. Then Let me use another color. Then 4.1 kg into 3 centimeter plus 8.2 kg into 2 centimeter plus 4.1 kg into minus 2 centimeter. It's all in bracket. When you solve for it, you will get 1.3 centimeter as your YCM. So we have found the location of center of mass. Its XCM is 1.8, YCM is 1.3. Let's check these values. You can check it at home. It's 1.1 over 16.4 kg, then M1, Y1. Check from the figure. M1 is here, its Y coordinate is 3 centimeter, right? Then M2 is 8.2 kg, its Y coordinate is 2 centimeter. This M2, its Y coordinate is 2 centimeter. Then you have M3, which is 4.1 kg, its Y coordinate is minus 2 centimeter. This is its Y coordinate is minus 2 centimeter. So by solving this expression, you get YCM equal 1.3 centimeter. So you can locate X is 1.8, Y is 1.3. So X is 1.8, this approximately 1.8, Y is 1.3. It is approximately here. Approximately, this is the location of center of mass of the system. Understand it. So this is the location of center of mass. 1.8 is its x coordinates and in centimeters, and 1.3 centimeter is on y-axis, right? Let us move first part of the question we have done. Then the second part we have to find acceleration. Acceleration of the center of mass. So to find the acceleration, we know from the equation which we obtained that net external force on the system of particles is total mass times the acceleration of the center of mass. That means direction of acceleration of center of mass is same as the net external force, and the magnitude of acceleration of center of mass is magnitude of external force over the total mass. For that, we will find first x component of external force, then y component of external force, then we will find the magnitude and the direction of external force, then we can find the acceleration of center of mass. So first I find F external x, that's x component of the external force, which is F1x plus F2x plus F3x. What's F1x? F1x is minus 6 Newton. Then plus 12 Newton into cosine of 45 degree. Then plus 14 Newton. When you make the calculation, it is 16.5 Newton. F1x is minus 6 Newton. F2x is 12 Newton times cos 45. F3x is 14 Newton. Let me explain it to you. See, F1 is parallel to x-axis, so it has only x component. It is pointing along negative x direction, so its x component is full magnitude and it is negative. Its magnitude is 6 Newton. Minus because of its direction. So I've written here minus 6 Newton. Then let's move to F2. F2 is partly along x, partly along y. Its x component will be F2 cos 40 degree, for cos 45 degree. Its magnitude is 12 Newton. So it will be 12 Newton times cos 45 and it's pointing along positive x. That's why plus 12 Newton into cos 45 degree. Then F3 x. F3 is fully along x direction and positive. Its magnitude is 14 Newton. That's why I have written here plus 14 Newton. So we have got F1x. Similarly, F external x we have what? Then we have F external y, which will be F1y plus F2y plus F3y. Now you can check it yourself. F1y is 0. F2y is 12 Newton into sine 45. F3y is 0. See, y component of one and F1 and F3 are 0. Y component of F1 is 0, y component of F3 is 0. So only F2 has y component, which is 12 Newton times sine 45. And you calculate it, it turns out to be 8.5 Newton. So we have found x component of net external force on the system. We have found y component of the external force. We can find the magnitude. Let us move to next page. Now the magnitude of the net external force is given by magnitude of the net external force is given by F external is equal to under root F external x square plus F external y square. Whole thing is in the root. The simple rules of vectors. Then you put the values which you have calculated. The 16.5 Newton square plus 8.5 Newton square, right? External x square, external y square, 16.5 Newton square plus 8.5 Newton square. So when you calculate it, it is 18.6 Newton. Check all these values at home. It is 18.6 Newton. So we have calculated the external force, magnitude of the total external force. And direction, this is magnitude of the net external force. Let me encircle it. 18.6 18.6 Newton. Now the angle made by net external force with the x-axis is given by, that will give us direction of external force. External force with the x-axis is given by phi is tan inverse F external y by f external x, this here external, let me make it clearer. So if it is here f external y divided by f external x. So to find the direction, you divide the y component with x component. When you put the values, it will be 27 degrees. Will be 27 degrees. This gives you direction of external force, and circle it 27 degrees. This is also the direction of acceleration. This is also the direction of ACM, right? Now the magnitude of the ACM vector, magnitude is magnitude of the external force over the total mass, which is 18.6 Newton over 16.4 kgs. 18.6 Newton over 16.4 kgs, which is 1.1 meter per second square. So we have solved the question. Let me summarize. This is the magnitude of acceleration of the center of mass. This is the direction of acceleration of the center of mass, right? So that means by showing the figure, figure will be jumbled. So I will not show this in the figure. You can do it at home. So acceleration of the center of mass will be pointing somewhat. It will be. I will do it rough, or you can do it at home. You can show it in the diagram which way acceleration of the center of mass is pointing. So I summarize. First, we found the location of center of mass. Then we found the x component, y component of the external force. From that, we calculated the total magnitude of the external force. We calculated the direction because acceleration and force are similarly directed. This is the direction of the acceleration of center of mass vector. Then we found the magnitude of the acceleration of center of mass. So this is all for today. Do your homework. This completes our unit first. Next time we will take unit second. Complete your notes from these lectures. Don't waste your time. Do your homework. Be sincere with your studies, and don't forget to subscribe my channel. Thank you. God bless you. Assalamu alaikum.